Everyone's kind of settled at this point. A few quick questions. How many people have heard of the Microsoft Web Sandbox or have looked at the Live Web's website? All right, good. So I have a new audience. I assume most of you are web developers. Hands up. Do you build websites? That should be an easy question. On your websites, do you guys have ads or include third-party scripts or build anything you would consider a mashup? All right. The interesting thing is we're in Vegas, and usually what I'll ask after that is I go, do you think you're a gambler? And when you're building a mashup or you're building a website that includes third-party content, you're essentially gambling. You're taking your security, you're taking the risk of security into your own hands. And that is kind of what I'm going to go over today with the Microsoft Web Sandbox. My name is Scott Isaacs. I'm a software architect in the Browser Tools and Platform Group. But I've been involved on the web at Microsoft for, 13, 14 years, basically since the web first came around. Way back in the early days, around the IE3, IE4 timeframe, I wrote the original specification for dynamic HTML. I helped create a lot of the HTML and CSS standards, the original ones that we all build our sites on today. Over the years, I've worked in Windows Live and MSN, helping describe the patterns and approaches that we should use to build our richer experiences and our richer applications. I built frameworks similar to what you find with the Dojo and prototype frameworks and so on. And what I'm going to share with you today is an architecture, a framework that we've been working on to help you build more secure websites, the Web Sandbox. I started out by explaining that you're gambling when you basically are building a site that includes ads or you're including third-party content. And I'm going to explain why Web 2.0 is broken. And more so, why there's really not much you can do about it at this point. And what I'm describing is the technology. The concepts, the scenarios that we're all doing are all perfectly great and wonderful and exactly what the web is about. But unfortunately, the technology underneath is fairly inadequate. So I could pick any site on the web. So this is nothing against Gizmodo. I could pick any website, and I'll find the exact same thing going on underneath. If I drill into the source of that page, eventually I'll find a script reference. In this case, I'm loading a script from sitemeter.com. This script is basically providing a very good service to Gizmodo. It's providing analytics about the visitors to the page. But the script has creates a number of issues for the Gizmodo site. One, this script, when it's loaded via an external reference, is running with the exact same permissions and rights as any script that you have written yourself for your own site. So this code can access everything on the page. It could talk to services back on that site's server. It could crash the page. It could destabilize the page. It could change at any point, so it's very hard to determine whether the script is valid. So why are we in this position? I mean, if this is such a problem, shouldn't we be trying to avoid it? Well, unfortunately, the Web 2.0 concepts that we all value are really still built on top of Web 1.0 technology. When I started thinking about this, I actually rolled back the clock a bit and said, where did mashups come from? The first mashup I was able to find was basically, if you think back to the mid-90s, you used to visit those sites that had a little image that would basically show you how many visitors came to the site. I think that might be the first mashup I could find. You basically had a RESTful service sitting on the back end that was counting every time that URL was requested and returning an image that looked like a counter. I remember my first website, first thing I did was put one of those counters on, and I hit F5 to make my site look really popular as the counter would increment. Now, the real mashups, though, that came about, again, still in the 90s, were affiliate programs and advertising. You're all familiar with Amazon. Amazon is the most well-known, but most e-commerce sites started to do this. They would allow you to drop a script on your page that would allow you to advertise things on Amazon and share in the transaction. So if Amazon made money on a purchase that originated at your site, you collect a small portion. The way those work is, again, you would just drop a script on your page and assume it's going to work properly. The entire advertising model of the web is built on this. You want to include ads on your site. Let's say you use Google AdSense. You reference a script from Google. You want to include a script from any ad provider. You include a script that references the ad provider. All of those scripts are basically being loaded and running in the context of your site. Things got really interesting in the last few years, and this is really where Web 2.0 came out. With Web 2.0 mashups, I kind of sum it up in a number of ways. But it really comes down to very low-cost innovation. When you think about Web 2.0, often people think about maps. If you want to build a site that had a map, and you had to build it from scratch, and you were just doing this in your garage, what are the odds that you would be able to go out and acquire all those map, license all the map technology and all the imagery that you need, that you would even be able to write that script for the map? It would be very expensive and very difficult. The odds are you wouldn't even try to do it. However, if you look across the web today, there's tons of very interesting sites created from major companies to the smallest guy in his garage that are integrating maps into their experience. That's what I call low-cost innovation. It's that desire to integrate capabilities provided by others to build new, richer experiences. We're now starting to see the real push in Web 2.0 to the platform. If you think about the web, it originated as a set of hyperlinks that link together web documents. You click a link, and it would take you from one page to another. That is quickly evolving now to be a hyperlink, to be much more involved, to interlink not just documents, but data, behavior, and services. Take Facebook Connect. Now, if you wanted to build a site that included a social network, would you build yet another social network? Or would you go find one, whether from Facebook or Microsoft or Google, and integrate it into your own experience? You would probably choose to do the latter. And you would then build and expand that web of integration and expand that web of innovation. But underneath all this is still that same Web 1.0 technology. So what is the state of the art? Well, for the most part, we're all gamblers. We mostly ignore the problem, or more explicitly, we just decide that the risk is acceptable. If you're building an advertising-funded site, you decide that the funds that you're going to receive from those ads outweigh the cost of you including a third-party script on your site, outweigh the risk that that script can destabilize your experience. What is interesting is how destabilizing those scripts can often be. How often do you visit a website where you see an arbitrary script error? I, as a web developer, browse the web with script errors all turned on, so I get a prompt every time a page fails. And more often than not, when a page fails, it is not the code written by that website. It was one of the scripts that were included on that site were causing the problem. The other way to address this problem is typically people iframe it. Throughout this talk, I'm assuming that you all understand what iframes and all these technologies are. If you have questions about them, feel free to ask me at the end. But with iframes, you could drop content from anywhere else in the web in the middle of your web page. Now, iframes are great because they provide isolation. So the content in that iframe will no longer be able to read the content of your web page. The content in that iframe will no longer be able to request data from your website services. So you're basically creating a nice wall between that untrusted code and your environment. But it doesn't come without cost. Take that map scenario. Maps are very interesting because you have an API you can communicate with. So they're very easy to aggregate and integrate into your experience. The moment you use an iframe, it is much more difficult. You basically have a box on your page that is hard to communicate with. HTML5 is attempting to address that with some simple message protocols. So you can send messages back and forth. But at the end of the day, iframes are still more an isolation solution than a security one. What can go wrong with iframes? Well, the content in an iframe is outside of your control. So you're assuming that content is safe. That content can still try to do a redirect. So the moment it loads inside your page gets redirected away to somewhere else. It could try to install a control and represent it looking like it's from the context of your own experience. It can interrogate your history. It can do something called clickjacking. It's a new, basically, security attack that if you want to learn more about, I suggest you go just search for it on the web. There's a lot of information. With this, I do want to point out, because I will forget later, Eric Lawrence, he's actually in the room over there, he could wave his hand, is giving a talk on IE8 security where they actually they're doing a lot of work to mitigate these risks. But at the end of the day, they're still real and they're still on your page. There's been a bunch of first-generation solutions. I don't know how many of you have heard of JSON, not the name, but the concept. Douglas Crockford at Yahoo came up with the term JSON, which is a big Web 2.0 concept on how you could serialize and deserialize objects. He also proposed something called AdSafe, which was creating a dialected JavaScript that can be statically analyzed to be secure. It's a great idea, but it hits a lot of walls. The DOM, while the script itself might be secure, you have to actually protect the boundaries that the code is executing from the surrounding page. Facebook.js is the first generation solution that does all of that. It protects the JavaScript layer, and it creates a DOM that defines the boundaries of how you interact with the page. This will all become much clearer in a few minutes when I get to the demos. But most importantly, none of these address quality of service. What was interesting is when we started this project, I interviewed a lot of people. And most people actually were less concerned about the security risks. They decided in the tightly coupled case, where they chose, I trust Microsoft for maps, that the odds of Microsoft compromising their site were pretty slim. But what they were more concerned about was the potential for those scripts to destabilize their experience, to generate errors that they can't recognize, and to bring down their website. So that is actually a big area that we've spent a lot of time investing in. So what do we want to do? We want to go beyond the state of the art. We want to build a framework and architecture that properly supports the scenarios that we're all building upon. Now, there's a few other projects that are actually ongoing in parallel to Microsoft's Web Sandbox. Google has a project called Kaha. It's analogous to the Web Sandbox. It's a solution that's going to allow you to build secure Web 2.0 sites. Facebook has evolved the original implementation to work in a very similar vein. Now, the reason why I'm bringing these up is that none of us are working in a vacuum. I don't know if you guys realize, but JavaScript is actually called ECMAScript in the Standards Committee. And the Standards Committee that works on the ECMA standard is the ECMA Working Group. Within that group, we have a security team that consists of basically Microsoft, Google, Yahoo, Facebook, all the usual suspects that are working together to figure out how to best address the Web 2.0 scenarios and how do we best provide a more secure environment. Together, we are all working on converging on a single standard. So what is the Web Sandbox? As I go through my demos, you're going to realize nothing new is going to be shown to you. If you know how to write HTML, CSS, or JavaScript, I'm not going to show you anything new in how you write your code. Rather, I'm going to show you how you could apply those concepts to build more secure and safe code. So we're going to focus on mashup security. I'm going to illustrate how quality of service can be protected and prevented from destabilizing your overall experience. I'm going to show you how we built browser equalization. Earlier in the keynote, you saw that great demo where they were showing expression, loading pages in different browsers to render correctly. Rendering is only one half of the problem. You've got to make sure your code actually executes correctly. Browsers implement APIs in slightly different ways. We also have an extensible engine, and that I'll just leave for the demos later. But the one point I do want to make it very clear is that this project we're releasing under the Apache open source license. This is the same license that the Google project is under, and we chose it for that reason. It's going to allow us to work better with not only the industry as a whole, but the community. So enough of the discussion, and let's just go start playing. All right, I'm showing you a typical little DHTML app. One of our developers created it. It's a breakout game. Now, I'm not going to show you actually how to write a game like this. I'm going to assume if you want, you could go write a bunch of DHTML and do this. What I'm going to quickly do is fire up this source, do a view source. The one thing you'll notice, I'm starting in Firefox. As I go through this talk, I'm going to rotate between all the modern browsers on the market. Everything you're seeing runs exactly the same with no modification from browser to browser to browser. We have no browser detection code anywhere in the code that you as a developer would write. It just runs transparently. I'm not going to expect you to be able to read this other than recognize that it's a standard HTML page. It's got a head element, a style. This is just a web page, as any other that you could create. Now we're going to quickly load this page inside of the Web Sandbox virtual machinery. I just refreshed the page just to start it from scratch, just making sure I have full network connectivity. And you'll notice I have the Block Bash game followed by a Tetris game. This Tetris game I actually wrote back in '95. It was our first DHTML demo. It's kind of neat. It still runs today, and I'm now running it in Firefox. So most of the technology really hasn't changed that much. The points I want to make with this is, one, no iframes. We were able to load that HTML page directly inside of another web page with no iframe. And the easiest way I could show this is I could select right through it. And you can see the selection spans through all the content. On the bottom, I have a Tetris game. That's, again, another HTML web page. If I showed you the source of that, you will see it's just a web page. So what is going on here? How are we loading this directly? I'm hoping this font is big enough that you can all see it. What you're seeing first is that we have a standard web page, and we're going to load the Web Sandbox library. We built the Web Sandbox library as a JavaScript library. this is how we're able to get ubiquity across all the browsers. This is just a script library. What you're going to watch requires no browser add-ins, no changes to any existing browser. It works in all modern browsers. We even tested this, and it works on some of the mobile phone browsers. The next thing we did is we loaded that block bash HTML. But instead of loading it directly, we requested it via a RESTful service. Our RESTful service basically does a transformation of that HTML and converts it into a format that we can virtualize inside of another web page. So you'll notice that we call our RESTful service. We basically said it's an HTML page. We can also just send it script and virtualized script. We give it a unique GUID, and then we give it the URL to the HTML we want to load. I know selecting is always a bad idea like this when you're trying to give a demo, but there you go. There's the original web page. Then we did the same thing for virtualizing Tetris. We called the RESTful service, virtualized the page. If I scroll down, on the bottom of the page, you'll see we just had 2 headers and 2 containers, 2 divs. And those divs have IDs on them. And what we did to instantiate that game was merely say, create a new sandbox on that particular element, apply the gadget capability. The word capability is going to come up a lot in my presentation. A capability is basically a set of functionality that you're either surfacing to the web page or the web page wants to surface to the code itself. In this case, the gadget capability is providing a virtual machine that can load HTML and execute all the HTML that you know and love inside of another web page securely. And we're going to use that unique GUID and say we want to instantiate the bash game. And then we're going to initialize it. Now, to show you really quick, I could actually load 2 instances of that block bash game without any changes to the code. The HTML developer just built a web page. And if I change this to bash, resave it, go back, refresh, we're going to get 2 independent instances in a moment of that block bash game. As I said, in a moment. There we go. We have 2 independent versions of that game running inside the same web page with no extra work by the developer. Let me just kill the game so it's not running. There we go. So moving on. The rest of my demos are mostly going to be run inside of this interactive playground. This page is the page that's on our Live Labs web sandbox site. I'll give you the URL later, where you can experiment and write your own HTML pages or reference one and run it inside of our virtual machinery. So I'm going to quickly do a few quick demos to kind of show you how this works. I'm going to create just a simple clock. And while I do this, I'm going to explain a few things here. Now, one of the problems you start running into as you build a web page and include different components and different pieces of code is the potential for collisions. I'm going to give this guy an ID of clock, and I'm going to go window on load. You'll notice, as I said, all this code that I'm going to write is nothing new. It's stuff that you should be familiar with. I'm not here to teach you JavaScript. I assume you all understand that. And I'm just going to create a simple clock. This is usually like the first thing you do when you learn DHTML. Clock, inner text equals new date. And assuming I have no typos, we're going to run that right on the page, and it's going to load, and we're going to get a clock. And again, no iframes are involved. If I select from out here through, you'll see I can select through it. We were able to load that HTML directly in the page. Now, one of the things to think about when you load third-party code is the risks that you're taking on. You're going to assume that that code cannot conflict with your page. I'm going to quickly load another instance of this clock, but I'm going to change the doClock function. Instead of going to do it to put the text inside the body, I'm going to have it set the title to the date. Now, where you synthesize the title, it's not going to go in the title bar. It's actually going to go above the gadget and run it again. And now you're going to see the clock in the title bar. Now, what's the point of this? It's like, fine, I created 2 clocks. If you were to write a library, actually a little bit of a story here. How many people in the room have used Dojo, Prototype, or an open source library? All right, a number of you. How many people know about the $ function that's in those libraries? You know and love it. I forget what library invented it first. But when that function was introduced, it was so immensely useful, every library decided to introduce their own $ function. Now, the $ function started out very simply as a shortcut to get element by ID. But certain libraries decided to augment that functionality and make it richer. Other libraries had different side effects. And then as these libraries evolved, web developers said, geez, I really like Prototype for its AJAX capability. And I really like this other library, let's say Dojo or jQuery, for its animation capability. I'm going to use them both on my page at the same time. And what happened? Well, that $sign function was defined by both libraries and collided. And the way JavaScript works is if it loads a function of the same name, it will replace the previous definition. So code started breaking unintentionally, and things started colliding. Well, the reason why I wrote this demo with do clock twice is you'll notice that we were able to have a function with the same name running inside the context of one web page with no collisions. We have two onLoad events that are focused on your own loading of the content, not the outer page. We have elements with the same ID, and I forgot to do this, so I'll just show you. Let's create another one where I'm going to set the style of the ID clock to red. I must have typoed. Hold on. There it goes. It just took a second. You'll notice that the text turned red. This avoids collisions. If I had a style sheet on an element tied to an element, they all should change color. And that could create the conflicts on your web page. Now, the last point I was making earlier about the risks that you take, a lot of people I spoke to, as I said, were worried about site stability. What if one of these scripts generates an error? And I'm going to quickly just force an error to occur. Document. We're going to hook the onClick handler in our code, and we're just going to throw an error. And we're going to run this. Now, typically what will happen, when an error is thrown on a page, you usually get the exclamation point in the lower left corner, or you get prompted that some script on the page has failed. The moment this happens, things could go wrong. The rest of your scripts may stop working. Well, you'll notice when I threw this error, nothing else on the page was impacted. I was able to isolate that error and keep it inside the scope of its own code without impacting the rest of the page. Your page could intercept this error and react in different ways. The default action is we shut down that code. And in this case, if I show you the details, you'll see the message from that exception. Now, it's kind of neat to show you a little bit of the AJAX nature of this virtual machine. I could just force reload that content right in the spot where it was without reloading the page. I could just say reinstantiate it. And I could click on it again, throw the error again. And that error had no impact on the rest of the screen. Going back. So moving on a little bit, I want to emphasize this because we're using what looks to be HTML pages. And typically when people say HTML, it's kind of foreign that we're loading it inside of another page. We chose the HTML pattern for its simplicity. The same model you're seeing, I could just write raw JavaScript and load it also in isolation. But for the sake of keeping our presentation simpler, we're sticking with the HTML pattern. But in not one of our demos are we ever going to use an iframe. So what is going on? Well, typically, this is a very high-level 10,000-foot diagram. You create a web page, you drop a script on it from that untrusted location, and you run it. Well, what we're trying to do is we wrap that untrusted script. And we put it inside its own set of virtual machinery that basically says, you know what, we're going to make sure that script only does things that we want it to do. And what defines what we want to do is by policies and rules. So what happens is when we allow script to interact with the DOM, we've built a capability that says, here's the DOM APIs that you can talk to. If you want to create a map, you would build capabilities that say, here are the APIs in the map you could talk to. The map can't talk to anything outside of it, and you can only talk to those specific APIs. And then we could do this as many times as we want on a web page, and it all will stay within our own machine. So dropping from 10,000 feet to, let's say, only about 5,000 feet. We're not going to get too deep yet. What is going on underneath the hoods? And I forgot to show you, and I'll show you on the next demo, what the virtual machine script looks like. I forgot to show you the generated code. I'll do that in a moment. But what is happening is we have that untrusted, your trusted site. That's your site. That RESTful service that I pointed out is a service that will go get untrusted content on your behalf and do an A to B transformation. And in the beginning, I mentioned first-generation solutions, how AdSafe tried to statically analyze the language. If you really study JavaScript as a language, you will recognize that the dynamic nature of it is one of its benefits. And that's also one of its downfalls. Since JavaScript is a very dynamic language that is also untyped, there's no strict type system, you cannot just look at code and view it and say it must be safe. you can't determine what the code is doing really till it executes. And this is simply because everything in JavaScript can be referenced late bound. The square braces that you could put code in to reference any property makes the code very hard to analyze. So we do this transformation so that when the code runs, at runtime, we can do our evaluation. And that's what's happening in the sandbox. So what is our pipeline? This is what the RESTful service is doing. The RESTful service is a server-based process that we provide, but since we wrote the code in C#, we were also able to compile it as a client-side Silverlight component. The client component is very useful for what I'm hoping you all do at the end of this talk is you can go home, take that component, have no dependency on our server, and try this against your own scripts. But what is that service doing? It's taking that untrusted content. The first thing it's doing is extracting all the HTML and converting it to JSON. That conversion is an optimization step. Parsing a big string of HTML is much more expensive than enumerating a JSON structure. The other thing we do is extract any inline event handlers. So if you have an onload attribute on your body tag, we extract that script and turn it into a function. We do the same thing for CSS. CSS were actually a little bit smarter. When you saw 3 or 4 instances of that block bash game running, if they had CSS specified, we're smart enough to share the CSS in a scoped way. So we're not going to create style sheets with thousands of rules as you create multiple instances. We package that with the script and do a transformation. I'll show you what that looks like in a moment. And it comes back to the client. When it reaches the client, we now have this JavaScript code ready to run. And then we call that new sandbox function to instantiate it. And every time the invocation occurs, we check it. So let me explain what I mean by that. Let's say you call the document property on the window. Very simple. You just want to get the document. What typically happens is the JavaScript engine says, oh, he's referencing that token document. I'm going to dispatch it to the browser off the global namespace, and the browser is going to return you an object. What we've done is intercepted all those calls. We built our own dispatch layer. So rather than dispatch the request for a document or any API right to the browser, it first gets dispatched to our virtual machine. And when it reaches our virtual machine, we make one of 3 decisions. We deny it, and that's actually the default. If we haven't made a decision, the call is denied. If you have any security background, you'll realize that whitelisting is much better than blacklisting. So we have to whitelist things to turn them on. That way we don't have to worry about if we miss something. The next decision is we allow it. We can allow it. We can just say, you know what, it's a safe operation. Hand it to the browser and let them do their thing. The third choice is we could say, we're going to implement it ourselves. We're going to create our own safe implementation to override the built-in one. So think back to that first example where I showed you 2 or 3 times that clock using the same ID. What our virtual machine was actually doing was masking those IDs. So while you thought you were talking to the element with the ID clock, you actually were talking that element, but internally we made sure that the version that you spoke to was the version you expected. And the last thing we do, while all this code is running, we monitor the quality of service for those errors or long-running code. So now we're going to jump right back in and continue with a few more demos. And this time, I'm going to say it to myself so I don't forget. I'm going to show you the input and the output code. Let me just quit. And we're going to switch. I believe this time we're going to run in Chrome. I think that's the Chrome icon. There we go. So I have my simple clock again. And we're going to start up the clock. I'm going to show you, here's the original HTML. If you think back to that diagram, this is the untrusted HTML that came into the system, right here. It's the same HTML that I typed up on top of the page. When it goes to our RESTful service, it does that transformation. What actually gets loaded into the browser is the code below here. It's a JavaScript library. We have any CSS that we specified. In this case, I didn't have any, so it's an empty JSON structure. And down below, you'll see that we have all the code that we wrote. There's the doClock function. It's put inside of a JavaScript closure. I'm not going to drill really deep into this, but if you're really interested, I'll be here the rest of the conference to go into details. But we create a JavaScript closure. If you're familiar with the JavaScript closure pattern, you can instantiate it, which will basically create its own lexical scope for all the code inside of it. So we're putting this doClock function inside of its own lexical scope, which will execute inside its own instance. So it's kind of hard. I should have made this window bigger when I generated this page. But here's the JavaScript closure. It's a function. And inside, we handed a context object, that's the letter A. And inside there, you'll eventually see that we put the doClock function inside that scope. That way, this doClock function will never collide with code outside any outer page. If the outer page in your own code, you wrote a doClock function, no worries. This one cannot touch it. And here's the onload event. And eventually, you see, here was the original HTML. There's the JSON structure. So that's kind of showing you what's going on. Now, I'm going to tell another story about JavaScript libraries. I already told the $ one. In the early heydays of the JavaScript libraries, when they were all first introduced, they all wanted to extend the base prototypes in the JavaScript language. If you're familiar with JavaScript, you can extend the string objects, the base object itself, and every object that's created will have those new properties. It was a very effective way for libraries to extend the language, and it was a great pattern. And it created problems. Everyone wanted to extend the object tag with their own methods. Like they add, I'm sorry, not the object tag, the base object. So let's say you wanted to create your own inheritance scheme. They would add a method, inherit from, to any object, and it would run. The problem was how do people enumerate objects in JavaScript? They use a for-in loop. And when they extended these base objects, the for-in loop got polluted with these new properties and code started to break. And it also got further problematic because libraries were extending their base prototypes in different ways with the same method names. And code collided again. So what most of those libraries decided to do was they stopped mucking with the core objects, and they basically started coming up with patterns, approaches that they agreed that they will use to avoid collisions. So the prototype library has their own namespace. They put all their stuff underneath their own object. The jQuery library does the same thing. The problem is, can you assume that everyone that writes their code is going to be aware of those issues and not do things to break you? So we're going to have a little bit of fun, and we're going to extend the prototype of the date. And we're going to introduce a transform case method. In this case, this is kind of esoteric JavaScript that allows us to say we're going to take the implementation of uppercase and put it on the date object itself. I'm hoping you can figure out what this is going to do, but it's going to turn anything we type to uppercase. Any date object to uppercase. You'll now see we have an uppercase date. Now roll back to what I said about JavaScript libraries and extending base prototypes. What if someone else decided to introduce a method of the same name, but they're going to transform the string to lowercase, transform the date to lowercase? Now if this was running outside the virtual machine and I had both of these things specified, right now both of those clocks would show up lowercase, even though the first one intended to be uppercase. So our virtual machinery was able not only to isolate namespaces, but it isolates everything about the JavaScript library. So moving on, we're going to go beyond security. And after these next two slides, I'm going to go into a long stream of demos. But another little story here. Some of the work I've done at Microsoft over the past few years was come up with patterns on a component model for Windows Live. How we built our rich properties, how we built our rich experiences. And the idea was, how do you build a component that you could reuse across all of Windows Live that we write once, that has no collisions and provides robustness? We used that pattern a few years ago to expose Windows Live web gadgets. It was a model for third parties to extend the Windows Live portal experience and spaces. The model we used was built on top of this really rich library. Now, me being a web developer, I looked at this library and said, wow, this is a great library. It's great stuff. People are going to love it. It provides abstractions around AJAX, abstractions around object lifecycle. They have to use this funky initialize, this funky destructor, so we could do multiple instances. It was pretty complex, but it was pretty complete, and I was excited, and we released it. A week later, I go run out to the web to see what cool things all those people in the web community are doing with this library. And I discovered that some smart guy out there built this gadget that basically provided a pattern of, I'll put an iframe inside the gadget and point to my web page, and that'll be the gadget I want to use. Because I didn't want to deal with that library that guy Scott wrote or try to read the SDK. I know how to write HTML. I'm just going to write HTML. So I looked at that kind of in dismay and thought to myself, what did I do wrong? Well, our documentation wasn't that great, so I started looking at that. Maybe the library is too complex, and so on. Well, around the same time, Google also introduced web gadgets on their site. And they had a library, and they had a schema. and it abstracted things. It was a great way of building things, and I looked at it and said, wow, that's cool too. And then a week later, I went to see what gadgets people created on Google's site, and I discovered something interesting. Someone built a gadget that created an iframe that pointed to a web page, and then everyone started building gadgets that way. Now that also got the neat benefit of, if they built it that way and used that pattern, they were able to make their gadgets run both on Google and our site very quickly. But it also taught me a lesson. I learned that the web community understands how to write web code, HTML, CSS. If they want to use a library, you will go choose to go use it. If you want to use jQuery or Dojo or Prototype, you will include it in your page. If you want to use our extra functionality, it should be a library. It shouldn't be a pattern that we force down your throats. So what we discovered was the best pattern was the patterns that you already understood. And that is why as you look at these demos, everything you're seeing is familiar. I did not try to go off and build an SDK. I did not come up with a new pattern on how to build secure pages. Rather, I'd rather let you use the knowledge you have and the libraries you're familiar with. But we did provide a lot of extra functionality. Life cycles. If you remember, think back to that early demo where I showed you I could reload the thing in place. We built life cycles directly in. But rather than come up with a sophisticated pattern, we built it on web standards. How do you know your component is initialized? Well, it loads, and eventually you'll get an unload event. Even if the page you're in is already loaded, you will still get your event. What event do you think you get when we destroy you? The unload event. Why did I need to invent something new? Automatic multi-instancing. Our original framework had a very complex pattern to ensure your code would not collide with other code. It was complex. Now you just get it for free. You build a web page, we will make sure the right things happen. Code throttling, leave that for a demo in a few minutes, and same with this last point. The other point I want to bring up is my early discussions where a lot of people were more concerned about quality of service. There's a reason I chose the site meter script in that first slide. Last August, SiteMeter released an update, and every site that used that SiteMeter script for that day crashed, IE. So everyone that visited a site that had that script on it would go with Internet Explorer, that site no longer worked. And that went on for about a day before people figured out it was that script and SiteMeter went and corrected it. It was an accidental mistake, but it was an unintended side effect of the script loading in an environment. Maybe it had something it didn't recognize or was familiar with. The real interesting thing about that story is all of us that have web servers and websites, I'm going to oversimplify this, but you have some guy running around with a pager to let you know if your server's up. When that SiteMeter script failed and all those websites stopped working, not one pager went off because your server was just great. Even more so, it wasn't even your server if it was a server problem because that script was coming from somewhere else. So you had no way of monitoring this in an effective way to even discover it unless you happen to visit your site with IE on that day at some point in time. So that isolation actually caused a lot of sites to break. Now the other problem is testing. Now when you first included SiteMeter, if you include Google Maps or Microsoft this or Yahoo that, you're going to test your site at that point in time. And you're going to say, wow, everything works great. But you're loading code from another destination that you don't control. That code could have changed at any point in time, unintentionally breaking you. That's why in the beginning I said you're gambling. You're assuming that your partners are going to do the right thing. In most cases, they will. And I can pretty much guarantee any of us major vendors are not going to be out there trying to break or do anything that will break a site. But things happen. The last point is the feedback loop. Eventually, if things go wrong, how do we get that environment like so your pager goes off? How do you know if something fails? How do you get notified? Well, our virtual machinery, whenever an error occurs, your host page can get notified of it, and you could choose to ping a service on your back end that will fire off a pager, and so on. Basically, we need to break that single point of failure. So moving back on, we're now going to jump over to Internet Explorer 8 for most of our remaining demos. And here, I'm going to start with the first step, which is, in the beginning, I told you that one of our goals was to normalize the browser differences. So I'm running IE8 right now. And what I'm hoping is if you guys watch me write this code, if you see something interesting about this. And the one thing I want to point out is the same code would run just fine in IE7, and it would run just fine in IE6. I don't know if anyone can see what is unique about this code. If you were to try to run this in IE. Feel free to yell it out. If not, I'll tell you once I'm done typing. By the way, this code is really not going to be very interesting in the scenario, but it's what I'm typing. So what I'm going to do is write a very simple code that is going to just display the current color of what you click on. Now, what I wanted to point out, which no one apparently wants to yell out any guesses of why this code is interesting in IE, I will explain. What? Add event listener. Thank you from the IE guy. IE, all the browsers have a rich event model for how you hook events. The IE event model is built upon the one that was originally proposed to the standard years ago. They use attach event, detach event, and they to hook events. The W3C standard has evolved since then, and the way the W3C tells you to deal with it is use add event listener and remove event listener. The other thing in the W3C standard and IE does differently is IE supports getting style information via properties on the element, current style and runtime style. The W3C standard, now I think this is more convoluted, but it's what the standard proposed, is to use get computed style and get property value off that object. So the point I'm going to make here is if you loaded this page in IE directly today in any version of IE, it wouldn't run. It's using APIs that IE doesn't recognize. But when we run it inside our virtual machine, assuming I did have one typo, color red, move, run, click here. We're told it's red. So what you just saw here is that we're able to program to W3C standards ubiquitously across all the modern browsers. We can normalize and fix the APIs, not only in IE, but in any browser. We can add custom APIs. We could change any behavior we want. And this gives us a lot of benefits. What was kind of neat is I played with this library Facebook wrote. It was an animation library. When I looked at that library, they had all these different paths for all the different browsers. But if you looked at the code closely, they had one path, which I would call the standards path, where if the browser supported the right set of standards, the code followed a certain way, and it ran. When we ran that code inside our virtual machine, the standards path was executed, and it ran exactly the same in all browsers with no side effects. So as web developers, thinking back to that expression illustration where they showed multiple browsers for testing, you can now write your code in a single way inside our virtual machine, and it works. Now what's interesting is, so far, I've only shown you inward-looking code that did not interact with the web page. So in reality, what I showed you could almost been accomplished via an iframe if you ignore some of the quality of service work. So how do you get outside your iframe? And here I'm going to kind of show you. We're going to go parent dot. And I'm just going to quickly write an on-click handler. And it's always fun to type in real time. Function. And we're going to go alert ev.target.noname. Oh, I hit refresh somewhere while I was typing. That was not good. We'll do that again. So what I'm going to do here is, the one thing I want everyone to realize is that if you're familiar with programming iframes, the way you would get out of an iframe, assuming that they were in the same trust zones, was using the parent property. So if I want to communicate with the outer page, I merely go parent dot. And hopefully I don't accidentally refresh it again. Target.noname. And we're going to run this very simple piece of code. And I'm going to use actually the on double click just because it's a little less obtrusive. And I'm going to double click right here. And you'll notice I clicked on the P tag. When I double click outside of my code, it displayed text area. Now the security guy in the room usually jumps up at this point and goes, wait a minute, you just accessed information or content outside of your own isolated unit. Well, in our rules and capabilities, we decided that W3C tag names, the tag names of your elements are not a security issue. If you disagree with me, you can easily disable this ability to do this. But I want to illustrate this to show the next point. There are things that are bad. For example, events by themselves are not an issue. The key what happens in those events could be. So if you hook a keyboard event, the fact that you could discover someone hit a key does not really leak anything. But the ability to discover what key they pressed could be an issue. The other thing I want to point out about isolation when you look at this code is I hooked the onDoubleClick property of the HTML element of the surrounding page. What would have happened if the outer page had a double-click handle already on that node? Well, without the virtual machinery, you would have just overrode the event handler, breaking the page. We're able to ensure that any event handler and anything you do will stay completely in isolation, even if you interact with the same properties of the surrounding environment. But moving on, we're going to, in this case, try to read the inner text property. And we're going to run it. When I double-click inside your own code, of course you can read the text that you created. No security issues there, no concerns. But what happens when I want to read this content? Oh, I'm running in debug mode. That's why, let me flip. Debug mode actually turns off our quality of service layer. I want to run this outside debug mode. So when I double-click here, we got this. And I double-click here, you'll notice an error occurred. You can't get the text of the surrounding environment. So we're able to protect that personal information you may have in your web page from the untrusted code inside of it. So just to kind of show again that we did not want to teach any new concepts here, let's say you wanted to do something that you weren't sure you'd be allowed to, or you can do in some cases and not in others. We made sure to build the system, security, everything that is being done is standard JavaScript. So even the security exceptions that occur are just standard. Security exception, get unsupported. So you can actually try and catch any of the exceptions that may be thrown to detect that something may fail. So now we're going to move on, and hopefully I still have it. There it is. And we're going to fire up a clock. Now, one of the things I mentioned in the beginning was that risk that untrusted code. Did I do something wrong with my code here? I have a typo. See, look at that. It was able to crash just the clock without bringing down the page. We're going to rerun it, and I still have a typo somewhere. Oh, wait a minute. There we go. I think I got them all fixed now. Always test your demos before you start your talk. But there we go. We got a ticking clock. And the reason I put that clock back up there is to make a point. We're going to start with, we're going to create another simple thing, document.document, and we're going to create lots of mistakes. And we're going to start with maybe not common programming errors, but I'm sure we've all done something that is the equivalent of that, the infinite loop. And we're going to run this code. Now, what would normally happen when an infinite loop occurs in a browser is eventually the browser will pop up this warning and says, something is going on. Your code's been running a long time. Do you want to stop the code? It's a great question, and you pretty much will have to say yes to that. The problem is the moment the user says yes to that, they didn't just shut down that code, they shut down the entire web page. So if any of that code on your page goes into an infinite loop, it can bring down the entire experience. So in our case, what we've done is we detected third-party code may be degrading the experience. Do you want to stop it? We were able to kill that code without having any impact on the other scripts on the page. So we're able to protect the overall experience from runaway code. Now we're going to have a little, just to show you again, I can reload it in place, fire up the infinite loop, shut it back down again. Now we're going to have a little bit more fun. We're going to do a few more instances. I'm a little more malicious, and I'm going to create the infinite laughing dialog box. This one's one of my favorites because when you get into an infinite loop like this, and I'm sure many of you have accidentally done this. I've done this a lot when I was debugging code with alerts. Next thing I know, uh-oh, I got this alert box. I can't get rid of it. There's no stop button. And basically, if this ever happens to an average user, they don't know what to do. They eventually usually restart the machine. Us more sophisticated users know about that great utility called Task Manager and go kill the browser and start over. Chrome actually introduced a pretty neat feature which says, stop showing me the dialog box. So at least the box stops showing up. But think back to the fact that the dialog box should be shut down in this context. But maybe there's a valid alert somewhere else in your code. You don't want to hide that one too. So eventually, our virtual machine is going to detect something seems to be wrong again. Now, I'm a glutton for punishment. I'm going to say, no, 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 keep laughing at me for a little bit longer. And eventually, this is the PM in me. Some PM will word this better. I say it still may be degrading the page, and we could shut it off. Again, it will stop, and the clock will keep ticking. Now, at this point, when I first did this demo, I had some smart guy in the room say I'm not going to create malicious alerts in the way you just showed me. Instead, I'm going to actually do it this way. I'm going to create an alert that's not tied to a single thread. I'm going to put the alert inside of a very tight timer. And I'm being malicious intentionally here, because I really want to see if I could trick the system. And assuming I did this right, we're getting the same laughing alert, but now it's occurring asynchronously. And what I mean by that, the first alert was in a tight while loop, so the code was executing over and over again. With the timer, it was being popped up, and then the browser would continue, then the timer would go off, and it would pop up again. Eventually, we will detect, whoops, I decided to torture myself a little more. We will detect it again, and we can stop it. Same idea. This is really important. Now, I'm showing you the quality of service layers that we've built in, but they're not perfect yet. It's actually very hard to analyze JavaScript code in real time. We've tried originally to do it based on time, how much time the code executed. And it turns out actually retrieving the clock in JavaScript is very expensive. So then we went to a statement-based. But then long-running statements would cause us problems. So we were going back and forth into these kind of circular issues. So right now we're basically statement-based. And if you really hit the system hard, you will discover there are ways to get code to run a long time and break us. Now I'm really quickly going to jump over to Safari for the next demo, because I really wanted to cover all the major browsers. Now, I made a comment about iframes not being truly secure. And one of the things that you can do in an iframe is interrogate the user's history. Now, what I mean by this is, if you display a bunch of hyperlinks on your page, and you give them pseudo classes, in this case, I'm going to say all hyperlinks are navy and all visited hyperlinks are red. And I'm going to scroll down, and you'll see the two sites I go to all the time, Microsoft and search.live.com, are red because I visited them. I'm now going to add a site I've never been to. I've never had a need to go there. Google. And you'll see it's showing up blue. Now, what is interesting is you can interrogate this and determine if I've never been to Google and then try to get me to go there or do something else. Now, if you access the style properties from the DOM outside of the virtual machine, you would discover the first two links are red and the third one is blue. But what we made sure to do underneath the hoods is always return the presentation, the properties that read those values, in the unvisited color. We're hiding that leakage of information. So it's much more difficult for developers to intentionally interrogate your history and figure out where you have and haven't been. And that is actually really important. Now that said, the way the system works, I'm going to explain it real briefly, because I have a challenge if anyone can figure out the case I missed. The way this works is underneath the hoods, when you go retrieve that property, we internally, without you seeing it, flip it to a guaranteed unvisited hyperlink, get the color property, and revert it back to its original style. And that was our implementation. It actually doesn't work. There's a few scenarios where we missed, and we're still working on them. If anyone thinks they know it, they can feel free to come visit me after the talk. So jumping back to IE, up to this point, I was kind of talking about capabilities. I want to reload this page. And the fact that the system is highly configurable. So far, I have not shown you the underlying virtual machinery, or what that virtual machine looks like. The virtual machine is essentially a big JavaScript library. And what that JavaScript library is doing is intercepting all the calls. So what are we doing when we intercept that call? So I was supposed to be right here. What happens is we work kind of like what vtables do underneath in an implementation where you're doing dispatches. So when you request the alert method, and that's the method we're going to play with. When you call alert, we look up the alert method on the object. In this case, it's tied to the global table. In the global table, we eventually have a list of what you can invoke. I stands for invoke. And there's the alert method. And we implemented alert in a unique way. The first thing we did was defer time. That is actually to remove any time the alert is displayed from our quality of service check. So when we're doing our long-running code check, if the alert's up for 10 minutes, the code itself didn't execute for 10 minutes, the user has to hit OK, then the code continues. The next thing we do is say we're going to augment the behavior, And all this wacky ternary operator here, all it's doing is normalizing the browser differences. Browsers handle null differently with alert. You don't really need to understand that, but we implemented alert. Now let's say I, as a developer, and wanted to build a rule that said, I don't want untrusted code to ever display an alert visually as a box. For the case of my scenarios, I just don't want to allow that possibility. But I am going to allow, if alert is called, a different behavior. So what I'm going to do is change the behavior of alert to set the default status to the string that they passed into the alert itself. Context is the context of the call. It gives you the sandbox the code executed in. It gives you the arguments, and it gives you the object. So what we've done here is we said we're going to call the set property on the window object, setting the default status to the first argument. And the reason we don't just set it directly is we want to make sure our virtual machine handles that assignment, because we may override the implementation of default status when it gets there and circulate on itself. So saving this, and we're going to quickly go we're going to quickly create an alert. Hello world. And if I did this, well, actually, when I run this, it's going to pop up an alert the first time because I didn't refresh the page after I changed it. We got the alert. Let me just make sure I save. Yep, I did save it. Now we're going to copy this code, reload the page with the changed sandbox, rerun it, click. And you'll notice hello world showed up on a synthesized status bar. If I really dig down, but it will take too long, if I show you the implementation for default status, it actually fired a notification to the host environment, and the host environment decided that the status bar for this code is going to display below it. So you can build your own implementation. Now, I also explained to you in the beginning that we can augment the APIs. Like we add event listener to the DOM for all browsers. So let's say I want to add a new method called alert time. In this case, alert time is going to do exactly that. It's going to display the time and pop it up on the page. So we need to augment because we're providing our own implementation. And we're going to go context.r equals alert. Now, I'm doing an intentional mistake here. I'm calling alert directly, and hopefully, if I make sure I have the comma, oops, I put that in the wrong place. I'm glad I zoomed out. The one thing to notice about our rule object is the big JSON object. And we chose a JSON structure for simplicity, so it's very easy for anyone to come in and augment the system. And we're now going to call alert time. And I'm going to copy this so I could reload the page. And if I do this right, when I call alert time and click, we got the time in alert. But wait a minute. I implemented an alert to display in the status bar. What did I do wrong here? Well, I didn't circulate this back through the virtual machine system. What I really wanted to do was go context.sandbox.invoke, on the window object, the alert method, and I'm going to hand in the argument to be new date. And assuming I typed this correctly, which is rare I do, but well, hopefully I did, and save it. And we're going to rerun this. Let me reload the page, put the code back, run, click here. You'll notice the date now showed up in the proper location. Now what is interesting about our rules system is it's built to always call back within itself whenever it has to deal with the DOM. So if we want to allow or disallow a specific HTML tag, you just go list the tag in the JSON structure and deny it. And then no matter how the tag is created, whether inner HTML, create element, or so on, it will recurse back into itself and deny it. So this is making sure that we dog food our own rule system as we walk through the code. So jumping back. So some fine print about what I've shown you here. Our goal is to support 99, really to support 100% of the language. But I was a realist, so I'll say it's 99% is what we'll probably hit. Our back-end transformation service is not as robust as we would like. It requires your HTML to be well-formed. So if you give us HTML with overlapping tags, or if your p tag does not have the closed p tag, which most of us at HTML sometimes omit, it will fail to transform. So if you go try our little interactive playground and just point it at an arbitrary web page, 99% of the time that web page is not 100% proper HTML and it fails to transform. That's not an artifact of the architecture of the virtual machine. It's an artifact of our transformation engine. Document.write is a really complicated beast. You could document write HTML that includes further scripts that could document write more scripts and more HTML and recurse into itself. We have fairly basic support for document write. You can document write HTML into the page, but we can't document write arbitrary scripts. And the more explicitly, the more general rules, we can't evaluate scripts on the client that are supplied as strings. So if you're familiar with JavaScript, that eval statement. We support eval for JSON structures, but if you try to eval an arbitrary JavaScript string, we will fail because that string will not have undergone that transformation process. The with statement in JavaScript. Just avoid it. There's no reason to use it. It's ambiguous in nature. It's one of those things the ECMA committee would love to remove, but it would break code out there. We don't support it. We know how to do it. We may add it, but it adds significant performance penalty. We do not yet support Silverlight or Flash within the virtual machine. The challenge is how do we, one, Silverlight and Flash inside of its own box will be its own security model. I cannot protect what Silverlight or Flash might do within itself. And furthermore, I can't protect the boundary if Silverlight or Flash could communicate with your outer page. It would be able to read the personal information. We have architectural plans and thoughts on how to address this. We just haven't done it yet. The real pain point that comes up is the performance trade-off. That library that I showed you with all those rules, just think about it. Every invocation that occurs is going against our virtual machine, and then it's handed maybe back to the browser. So it used to be a direct call to the browser. Now actually gets handed off to some JavaScript that processes it. Obviously, that's going to add overhead. And we've calculated the averages between 1.5 to 4 times hit to any code running in our virtual machine. But what we also discovered is the scenarios that we're targeting, you would not build a Hotmail, you would not try to use this at this point for code that you've written yourself and you trust. And the code that you typically don't trust is narrow enough in scope that the performance overhead doesn't hurt you. The transformation step. It's a little more complicated. Instead of just pointing to a script on a third-party server, you got to go get that script transformed and then load it. One of our goals that we're trying to figure out in the standards committee is what are the minimal set of hooks we could propose to the standard to eliminate that transformation step so we can build more efficient systems. The question will probably come up, so I'll just address it. What I'm showing you is a JavaScript library. It's basically kind of something we put alongside all the current browsers. So when would you see this in the browser? The answer is I don't know yet. Security is a really tough problem. And to get this right is not something I want to just rush off, tell some of the IE guys, tell them, go build all this stuff into the browser for me because it'll make things faster, more efficient. Because guess what? We make a mistake in this, in our rules. It's simple. I go into that big JSON structure and I quickly tweak it. I pop a new script. It's fixed. Imagine we try to build this into the browser and we make a mistake, which we will, or anyone that tries this will make a mistake. It's a lot harder to patch the browser. So we want to make sure we really got this right. Furthermore, the whole idea of capability-based security is relatively new to the web. And if anyone understands security models, if you squint at this, it's really built on top of a capability-based system. The last trade-off is debugging. You're running transform code. If it fails, it's a little more tricky to actually figure out what went wrong because it's not the code you originally wrote. You can disable our quality of service layer in our playground with that debug equals true flag. When you add that flag, it turns off all the quality of service metrics, so if a code fails, you'll get your typical script error and so on. Last, and these are kind of the action items, as I said, the client-side library is an open source library. My goal in presenting this is a number of things. One, I want you all to be aware of the issues and challenges that we all face in the websites we build today. It's a tough problem. Even if you continue to choose to ignore it, just be aware of what is going on. Make sure your management is aware that when you're including that script, that sometimes things might go wrong outside of your control. I recommend you go look at websandbox.livelabs.com. That's our site, and there you'll find that interactive playground. We have documentation that has tons of samples that you can run just by clicking a button. What I would love to see is people trying to break us. Let us know where things went wrong. Try putting your libraries, use that client-side component, or use our RESTful service, build web pages that load the scripts and let us know. And we have community forums, including a full disclosure forum. Since this is basically an experimentation, an exploration, we're not trying to hide behind security issues. You're not going to email them to some dead alias and hope we reply. We want them posted publicly so we can acknowledge them and recognize them and address them as quickly as possible. So we actually have a forum up there focused entirely on disclosure. And another point, due to the fact that we're so freely working on disclosures, it should be evident that this is really not ready for widespread production use. Feel free if you want to, but I would not recommend you put this on a production site at this point and rely on it and bank on the security aspects. It provides a lot of value, but just understand that where we are in the process. And at the end of the day, I'm hoping that next time I stand up here and present and talk to you, we'll be talking more about the standard, what Google and all of us in the industry are working on together, and how we're going to get this to interoperate. And with that, I'm open for questions. Actually, I'll leave this page up if people want to write it down. Thank you. And there's a microphone right here. The last point is, if you do leave, I believe you have evaluation forms. I'm just going to do the little spiel. The woman in the back, hand them to her, and make sure that you do that on the way out. Yes?
So how do you see change management of the extensibility offered by this library? So if you do start to extend it, how do you merge in updates later? And how eventually would you do that once it's supported by the browser natively?
That is an absolutely great question. And since there's a microphone, it's the first time I don't have to actually repeat the questions. At this point, I'll admit I'm basically ignoring the issue. My hope is this. Since we're in the early phase, I'm hoping that as we work together, a set of default capabilities fall out that we standardize on. So right now, I didn't really drill into much detail. You saw that policy.gadget capability. Another way to look at that, if you're familiar with the HTML history and HTML, I'm doing HTML transclusion with behaviors into a page. We should be able to find a single standard that would provide that set of functionality. Now, take maps. I don't believe we've done this yet, but right now, if you use Microsoft Maps or Google, they all have different APIs. Once you have a capability-based system, I would just hope, and I say hope because there's not a plan, that you'll basically see convergence. If you're familiar with microformats, it's almost the same thing as the microformat model. Microformats, you have microformats for calendar events. No one sat down and said, I'm going to define that standard. They're letting basically the community converge on its own. And I'm basically following that model now. Now, what'll get trickier, which is the second half of your question, which again, I'm not going to have a great answer for, is even if we converge on a standard, how do you manage change? Because change will happen. There, what I'm hoping we'll do, and I'm just going to speak hypothetically off the top of my head, is we'll have versioning. And you'll be able to kind of list versioning. These are JSON structures. It's not going to be hard to envision support, especially since it's a library, to deploy different versions and run them side by side. Every virtual machine can, in theory, be associated with its own set of rules and capabilities, and every instance can have its own set. By the fact that that's built in, it gives us the opportunity to support multiple versions running on the same page. Now, collisions, fine. I can keep going. Basically, it's a tough problem. It's one of those that I know there's a ton of industry expertise in this area, and I'm hoping just to embrace and leverage the best of it as we move forward. Any other questions? One last point. I'm wandering around this conference for 3 days. I have my notebook at all times. If you want to talk to me offline, you didn't want to get in front of a microphone, you want to just sit down and drill into any of this into real detail or depth, just feel free to grab me. That's what I'm here for.